The goal of this short video is to talk a little bit about WeBWorK section 1.2 problem 5. And in this problem, you're given the formal definition of a limit, and then you're supposed to try to change a little bit to give a formal definition for what it means if a limit doesn't exist. So I just want to talk a little bit about that. So we have the formal definition. I put it here. Mathematical statement, limit as x approaches c of f of x equals L means, and I've taken the definition and I've split it apart into 4 pieces. For every epsilon greater than 0, there exists a delta greater than 0, such that for all x satisfying 0 less than the opposite value of x minus c less than delta, we have f of x minus L is less than epsilon, right? So this is just our definition that we've seen before. And now what we want to do is try to change this to talk about the definition of, or what it would mean if a limit doesn't exist. And so really what we need to do here is we want to go through and we want to try to appropriately negate this statement. And so I've broken the definition apart into these 4 pieces because I want to think about negating each of these 4 pieces. And I'm not going to tell exactly the answers, right? This is the homework problem and I want you to think about it. But here's some ideas. So if we were trying to say the limit as x approaches c of f of x is not equal to L, then we want to think about negating each of these pieces. And so some ideas here. The definition starts out with for every epsilon greater than 0. And so we want to think about negating this statement. The way that you would appropriately negate a statement that says for every epsilon greater than 0 would be to say, well, it's not true for every epsilon greater than 0. Or in other words, there is at least one epsilon greater than 0 such that, and then something else goes on. And then you move on to the next place and you say, well, there exists a single delta greater than 0. And so the opposite of there existing a delta greater than 0 should be something like, well, for every delta greater than 0. And so what you want to do for this problem is kind of work through this entire definition and try to appropriately negate all of these statements. And it may take a little bit of trial and error, and that's fine. I want you to spend some time thinking about it. But there are some ideas, at least to get you started with. Your problem should start with, there is some epsilon greater than 0 such that, and then continue working on from there and see how far you can get.